So hi folks, we're now on our next video on factorization, and in this video we're going to talk about the difference of two squares, which is still part of our college algebra playlist. Now the difference of two squares is kind of, it's one powerful um, factoring procedure or pattern to think of. What we're going to see here is that when we see one term is a perfect square. Okay, when you say perfect square, so it's such a way that if you're going to get the square root of it, it's going to be whole. It's not going to be irrational. So say, in essence, when you have a square, a perfect square, meaning if you're going to get the square root of it, it's going to be equal to the number a. So any square, get the square root, it will be equal to the number a. Same with the letter b, it is a perfect square also. And the last um, requirement is that there should be a minus sign in between them. Okay, so again, first term is a perfect square, second term is a perfect square, and there's a minus sign in between them. So what will happen if this is the case? Get the square root of the first term, write it here. Get the square root of the first term, write it here. Get the square root of the second term, write it here. Get the square root of the second term, write it here. Put a plus on the first grouping. Put a minus in the second grouping. And that's it. Okay, so to give you a very rough example before we go here, say you have x squared minus 4y squared. So if that's the case, x squared is a perfect square, 4y squared is a perfect square, including the coefficient because square root of 4 is positive 2. So what are we going to do? We're going to write it in this way automatically. So x, that's the square root of x squared, 2y, close parenthesis, x, 2y, and make sure there's a plus sign in one of them, there's a minus sign in one of them. So this is the pattern, a very powerful one, and we call this as the DOTS, or the difference of two squares. Okay, now let's try this example. So for number one, we're looking at number one here. This is a perfect square, this is a perfect square, and they are separated by minus signs, so that's a perfect one for our difference of two squares. So what we're going to do, put here, square root of x squared is x, square root of 16 is, square root of 16 is 4, close parenthesis, do the same thing here, and then put a plus sign and a minus sign. That's it. Okay, pretty simple, right? And powerful too. This is a perfect square. Yes, 3 is square. The square root of 3 is 9. 25 y squared is also a perfect square. Square root of 25 is 5, and we have a minus sign in between them, which makes it perfect. So yeah, square root of 9x squared is 3x. Square root of 25y squared is 5y. Close parenthesis, open parenthesis rather, 3x and 5y. And then put a plus sign here, put a minus sign here, and this is our answer. Okay, so yeah, pretty much that's the difference of two squares. Next, let's have more examples. 81x to the fourth. Yes, it's a perfect square. Um, that's the 81 is squared. The square root of 81 is 9. Square root of x fourth is x squared. Okay, and 169 is actually 13 squared. So if you want to check, 13 times 13 is going to be 1 vertically crosswise 6 9. So 169 is equal to 13 squared. So and then y to the fourth is y squared as its square root. So let's have this. This is going to become 9x squared here, and then 13y squared, close parenthesis, 9x squared here, and 13y squared, close parenthesis, put a plus sign in between, put a minus sign in between, and that's the answer. Okay, that's the answer. Maybe in number 4, you can pause first before I will proceed to my answer? Okay, so that's it. 64 is actually 8 squared, 49 is 7 squared, and a to the fourth, 8 to the 8, a raised to 8 is, the square root of it is a to the fourth. Um, y to the 8, the square root of it is y to the fourth. So taking this as our two terms, so we have 8, a to the fourth, 7, y to the fourth, close parenthesis, open parenthesis, 8, a to the fourth, 7, y to the fourth. And then we're going to put the plus sign here, minus sign here, and that's your answer. Okay, and that's your answer. Okay. Um, oops, in a while. Okay, here. So for number 5, we have 2401 x raised to 8 minus 625 y raised to 8. So this is quite challenging, but let's do this. Okay. It's quite just difficult to find the square root of 2401. It needs to have some testing of how to get the its square root. But you can trust me on this, that the square root of 24 24 2401 is positive negative 20, is positive negative 49. Okay, let's just get the absolute value. Okay, positive negative 49. So let's use the value of 49, and 625, the square root of 625 is 25. Okay, so let's use that. So we have 49 x raised to 4, and we have raised to 4, and we have 25 y raised to the fourth, and then do that in the same manner as another grouping, 49x to the fourth, 25 y to the fourth. And what we will do is put a plus sign here, put a minus sign here. Okay, but that's not the end. Okay, that's not the end. So yeah, we have executed correctly the difference of two squares, but wait, there's more. Okay, what we can further do is that we can further apply the difference of two squares here. Notice this is a perfect square, this is 7 squared, and this is also a perfect square, this is 5 squared. Okay, and by applying the difference of two squares again, maybe we'll copy this. This is not difference of two squares because this is simply a sum, okay, not a difference. So we have 49 x to the fourth plus 25 y to the fourth is equal to, yeah, 49 square root of 49 is 7, 7x squared. Then we have 25, oh no, 25 squared root of 25 is 5y squared. And then let's do that also in the another grouping, 7x squared and 5y squared. Okay, and then let's put a plus sign here, let's put the minus sign here, and then that's our answer. um let's make use of the blue one so that it will be visible. Okay, so this is our answer for our number 5. Okay, 49x to the fourth plus 25y to the fourth, uh, in a one grouping, 7x squared plus 5y squared quantity times 7x squared minus 5y squared, and we cannot simplify this anymore. These are not perfect squares. And then let's have the last example. So 1296. What is 1296? Square root of 1296. So believe me, square root of 1296 is equal to what? What is the answer? Okay, it's 36. 36. And we know the square root of 16 is 4. Okay, so how do we do this? 36 x to the fourth, 4y not really the fourth squared rather. 36x squared, 4y squared, and we have 36x squared, 4y squared. And this is going to be plus, it's going to be minus, oops, okay. And then further, just like number 5, we can do another DOTS in this part since it's a difference of two squares again. How do we do that? Let's copy this first. 36x squared plus 4y squared, oops, 36 squared plus 4y squared. And square root of 36 is 6. Only 6x, which will be left. 6x. Okay. And then we have 2y. So 6x. And we have 2y. Oops. Okay. And then the common one to do, we put the plus sign here, put the minus sign here. And yeah, that's our answer for number 6. And that's our final answer. That's our final example for difference of two squares, actually. Oops, it overshoot. Okay, so that's our answer. Okay, that's our answer. Yeah, my pen is lagging again. So yeah, it's lagging now, big time. Okay, there. Okay, so that's our answer for numbers 1, 2, 3, 4, and 5, 6. 5, 6 is quite challenging because we extend the DOTS twice. We apply the DOTS twice in this given scenario. So practically, it's still the same concept. We are still using this concept here, the difference of two squares. Okay, so that's it for our this video, the difference of two squares. Thanks for watching. I hope that that sticks in your mind and how to apply the difference of two squares in a binomial. Okay, so thank you very much. Don't forget to like and subscribe. And yeah, I'll be seeing you soon. Okay, see ya. Bye bye.